March 3, 1944, East Anglia, England. Lieutenant William Overstreet gripped his pencil as he wrote to his sweetheart in Virginia, his hand trembling slightly from fatigue rather than fear. Tomorrow we're attempting something everyone said couldn't be done, flying all the way to Berlin and back in a single-seat fighter. The higher-ups insisted it was impossible. Through his quarters window, he watched ground crews laboring under floodlights, fastening strange cylindrical shapes beneath the wings of his P-51 Mustang. They looked almost like they were made of cardboard, these new fuel tanks wrapped in brown paper like parcels from home. Some of the men jokingly called them paper bags. The crew chief had chuckled when Overstreet questioned their reliability. "They're made of laminated paper and plastic resin, Lieutenant. Same stuff the Brits use. They'll hold fuel long enough to get you there and back." The mathematics of aerial warfare were about to be rewritten, not through heavier firepower or advanced metals, but by compressed paper soaked in resin, produced in a converted newspaper plant by workers who usually printed the London Times. The crisis had reached its breaking point on October 14, 1943, Black Thursday. Colonel Hubert Skerr stood before the operations board at Halesworth, watching mission reports arrive like casualty lists from the Western Front. 60 B-17s lost. 600 men gone in one day. Of the 291 flying fortresses sent to strike Schweinfurt's ball-bearing factories, 60 were shot down by German fighters and flak. Another 17 were so badly damaged they had to be scrapped. The losses amounted to over 26% of the attacking force. Without long-range escort, the daylight bombing campaign was bleeding to death over Germany. Among the survivors who limped back to Thorpe Abbotts that day was Technical Sergeant Robert Morgan, ball turret gunner on AB-17 of the 100th Bomb Group. His statement to intelligence officers was grim. "The Jerrys waited until our little friends turned back at Aachen. Then they came at us in waves. Head-on attacks, rockets from twin-engine job sitting just outside our gun range. We were sitting ducks for 3 hours. The P-47 Thunderbolts, magnificent as they were, could only reach 375 miles with their standard drop tanks. German interceptors simply waited beyond that invisible boundary in the sky, then tore into the bomber streams with chilling precision." In a modest office at the 8th Air Force Technical Section in Bovington, Colonel Cass Howe examined something that looked more like an art project than a piece of military hardware. It was a fuel tank made of laminated craft paper infused with plastic resin, produced by Bowater Lloyd of London, the same company that normally supplied newsprint for Fleet Street. Howe had spent months refining this unlikely solution to the range problem, working with British engineers who had already experimented with non-metallic drop tanks, alongside Colonel Bob Schaefer. The British had begun out of necessity. Their aluminum supplies were critically low, every pound of metal precious. But Howe saw another advantage. These paper tanks weighed roughly 50 pounds empty, compared to 150 for the metal kind. That weight difference directly translated into increased fuel load and extended range. The tanks were built from multiple layers of craft paper bonded with resorcinol formaldehyde glue, shaped over wooden molds with internal wooden anti-slosh baffles, and then coated with fire-resistant lacquer and aluminum paint for a distinct silver finish. The first combat trial took place in February 1944, when P-47s of the 56th Fighter Group flew using the British-made 108-gallon paper tanks. Major James Goodson led the mission, later reporting that the tanks performed flawlessly to Hanover and back with no leaks or failures, boosting range by 125 miles. But that was only the beginning. The transformation accelerated with the arrival of the P-51B Mustang at Debden in late February 1944. Colonel Donald Blakesley's 4th Fighter Group, comprising the 334th, 335th, and 336th Squadrons, received their first Mustangs on February 28. Pilots had less than 24 hours to transition from their Thunderbolts. Captain Don Gentile, who would soon become one of the war's top aces, logged only 45 minutes in the Mustang before flying his first combat sortie. But it was the pairing of the Mustang with the paper drop tanks that changed everything. The P-51 could carry two 108-gallon tanks, now mass-produced at Bowater Lloyd's factories in Sittingbourne and Kemsley. With these tanks, the Mustang's combat radius stretched to 850 miles, putting Berlin, 580 miles from East Anglia, suddenly within reach. The morning briefing at Debden on March 4, 1944, crackled with anticipation. Intelligence Officer Major John McCulpin pulled back the curtain covering the mission map. A red ribbon extended from their base all the way to Berlin. For the first time in history, single-engine fighters would escort bombers to the German capital and return. The 1,100-mile round trip marked a historic breakthrough that would redefine the entire strategic bombing campaign. Captain William O'Brien of the 357th Fighter Group recalled that moment decades later. You could hear a pin drop. Then someone whistled, "Berlin." We were going all the way to Berlin in fighters. The crew chiefs had been fueling those paper tanks since 0300 hours, taking care not to overfill. The tanks could safely hold fuel for about 5 hours before the gasoline began degrading the resin. But 5 hours was enough. The engineering behind these paper tanks was deceptively advanced. Each was composed of 3 main parts: nose cone, tail cone, and body. The central section consisted of layers of impregnated paper wrapped around a cylinder, while the ends were hand-laminated with petal-shaped pieces called gores. Each tank carried 108 U.S. gallons of 100-octane aviation fuel, sometimes listed as 110 gallons total, with 108 usable. They measured 100 inches long and were pressure-tested to 6 psi. They performed reliably from sea level to 40,000 feet, functioning in temperatures from -60 degrees Fahrenheit to +120 degrees Fahrenheit. Workers at WWII, many of them women formerly employed in newspaper production, along with small workshops and distributed manufacturing across Britain, produced these tanks in growing numbers. By mid-1944, the American aviation establishment still doubted them. Right field experts dismissed the paper tanks as completely impractical and unfit for purpose. Yet, by the time that report reached England, the 8th Air Force had already used more than 15,000 paper tanks, without a single failure caused by their construction. Colonel Hal's response was characteristically direct. He continued pushing production forward, knowing that combat results spoke louder than laboratory assessments. The skepticism from right field became irrelevant in the face of operational success. The first escort mission to Berlin on March 4 saw P-51 Mustangs and P-47 Thunderbolts accompany over 700 heavy bombers to the Nazi capital. Leading the Mustangs was Colonel Blakesley, whose pre-mission briefing to his pilots was recorded by intelligence officer Captain John Slater. "These paper tanks will get you there and back. When you hit the initial point, punch them off and engage any enemy fighters. Remember, with these tanks we own the sky all the way to Berlin." The mission was not without losses. The 4th Fighter Group lost Lieutenant Alan Bont, who was shot down by flak near Brandenburg. But the psychological impact on both sides was profound. Luftwaffe pilot Oberleutnant Heinz Knock, flying with Jagdgeschwader 11, recorded in his diary that night his shock at seeing American fighters over Berlin, noting that their intelligence had insisted this was impossible and that everything they had been told was wrong. For the bomber crews, the sight of Mustangs over Berlin was transformative. Ball turret gunner Sergeant Dale Rice of the 100th Bomb Group later testified in official debriefings about approaching the initial point when he saw P-51s at 30,000 feet with contrails streaming. One waggled its wings as it passed over them, and he could see the drop tanks under the wings. The impact was immediate and dramatic. On March 6, when bombers returned to Berlin with Mustang escort, Luftwaffe interceptions decreased significantly. Major Walter Noten, one of Germany's top aces with 258 victories, reported to Luftwaffe High Command that the Americans had solved the range problem and that their tactical advantage was gone. The production chain for paper drop tanks exemplified Allied industrial cooperation and innovation. WWII, which had been producing 60% of British newsprint before the war, converted portions of their facilities at Sittingbourne and Kemsley to tank production. The company's experience with paper lamination and their access to raw materials made them ideal for this work. The kraft paper came from recycled newspapers and packaging materials, while the Ressourcenol formaldehyde glue was produced at Imperial Chemical Industries plants using materials that didn't compete with Other war priorities. The entire production process from raw material to finished tank took approximately 72 hours. Additional production came from distributed manufacturing across Britain, with workers in home workshops contributing to the war effort. The tanks were wrapped in heavy brown paper for shipping and could be transported efficiently with far more paper tanks fitting in transport aircraft than metal tanks. Master Sergeant Donald Manor of the 357 Fighter Group responsible for drop tank logistics at Lyon kept detailed records that survived the war. His team would begin work at 0200 hours. On mission days, unwrapping tanks, checking seals, and mounting them on aircraft pylons. The mounting system was elegantly simple, with tanks attaching to standard bomb shackles with a quick-release mechanism. A pull of a lever in the cockpit would jettison both tanks simultaneously, essential for combat maneuvering. The fuel feed system used the aircraft's existing plumbing with check valves preventing fuel loss when the tanks were released. The critical limitation was that the resorcinol glue would slowly dissolve from the fuel's solvent effects, causing leaks within hours, making these strictly single-use items that had to be filled immediately before takeoff. By May 1944, the impact of long-range fighter escort was measurable in stark numbers. Before the introduction of effective long-range escort, the 8th Air Force experienced catastrophic losses. October 1943 had seen monthly loss rates of approximately 7.6%, with individual missions like Black Thursday reaching 20.6%. Once P-51s with drop tanks began regular escort missions, the overall campaign loss rate dropped to between 1.5 and 2.2%. This dramatic reduction saved thousands of aircrew lives and made the strategic bombing campaign sustainable. Technical analysis by Republic Aviation. Engineers revealed unexpected advantages of the paper tanks beyond weight savings. They had better aerodynamics than metal tanks, creating less drag. They were also less likely to explode when hit by enemy fire, as the paper and resin construction would tear rather than fragment. The tanks were partially biodegradable, breaking down within months when left in fields or forests, unlike metal tanks that became permanent hazards to farming. Lieutenant Colonel John Meyer, who would end the war with 24 aerial victories, flew the March 6 mission to Berlin. His combat report, preserved in the National Archives, provides detailed pilot perspective on the paper tanks. Performance at altitude. He took off at 10:45 hours with 108 gallons paper drop. Tanks experienced perfect fuel transfer throughout the flight, released tanks at 1,347 hours near Wittenberg when bounced by FW-19S, and engaged immediately after release. The weight difference after dropping the tanks dramatically improved aircraft performance. He shot down one FW-190, damaged another, and returned to base with 45 gallons remaining. Without those paper tanks, he noted, they would have turned back at Brunswick. The strategic impact extended beyond just bomber protection. With extended range, American fighters could conduct fighter sweeps deep into Germany, attacking airfields, rail yards, and targets of opportunity. Colonel Hub Zenka, commanding the 56th Fighter Group, conducted a tactical analysis in May 1944 that concluded the extended range provided by British paper tanks had fundamentally altered the air war, allowing them to seize the initiative completely. German response to the Allied range advantage was documented in captured records after the war. A technical intelligence report from Messmit AG dated May 15, 1944, acknowledged that the enemy was using disposable fuel tanks of revolutionary construction with laminated paper and phenolic resin impregnation. They had attempted to duplicate this technology, but lacked the industrial infrastructure for mass production. The German attempt to copy paper tank technology failed not for lack of technical knowledge but due to systemic problems in their war economy. They lacked paper production capacity, with most German paper mills converted to producing military maps and documentation. The resin materials were prioritized for aircraft construction. Most critically, They lacked the distributed manufacturing model that made Allied production so resilient. The Luftwaffe's senior leadership understood the implications immediately. In post-war interrogations, high-ranking Luftwaffe officers acknowledged the strategic impact of long-range fighters, while the specific quote often attributed to Hermann Göring about seeing Mustangs over Berlin cannot be verified. In primary sources, documented testimony from the U.S. Strategic Bombing Survey shows he stated that long-range Allied fighters delivered a major strategic blow to German planning and were one of the most decisive factors in the ultimate outcome. He acknowledged that when fighters appeared over Berlin, the results would be, in his words, tragic for Germany. General Diegfleger Adolf Galland similarly testified that American fighters ranging over all of Germany with impunity had effectively broken the Luftwaffe's defensive strategy. By June 1944, paper drop tanks had become standard equipment for fighter operations. Sergeant James Patterson, quartermaster at Duxford, maintained logistics records showing that paper tanks required 1/10 the shipping space of metal tanks when transported from factory to airfield. A single C-47 transport could carry hundreds of flattened paper tanks, compared to 40 metal tanks. This efficiency meant forward airfields in France after D-Day could be supplied by air, maintaining operational tempo even when ground supply lines were stretched. The environmental impact, though not a consideration at the time, was documented by French farmers after the war. Metal tanks that littered fields killed cattle, damaged plows, and required extensive cleanup lasting years. Paper tanks dissolved in rain over winter, leaving only metal fittings that could be sold for scrap. Captain Donald Bryan of the 352nd Fighter Group experienced one of the rare tank failures on July 18, 1944, the only documented case in his squadron. The port tank developed a leak at 25,000 foot over Hanover, losing about half the fuel before he could switch it off. He still made it home with fuel to spare from the starboard tank, demonstrating the redundancy built into the system. Technical improvements continued throughout 1944. Second-generation paper tanks featured improved resin formulations that extended fuel storage time from 5 hours to 12 hours, allowing pre-mission preparation the night before and reducing ground crew workload during critical pre-dawn hours. The tanks also received better cold weather treatment, preventing fuel line freezing at high altitudes. The D-Day invasion on June 6, 1944, showcased the complete transformation that drop tanks had enabled. Fighter bombers with paper drop tanks ranged far inland, disrupting German reinforcements hundreds of miles from the beaches. Captain Robert Johnson of the 56th Fighter Group flew 3 missions on D-Day, each time with paper drop tanks, allowing him to loiter over the battlefield for extended periods. The ability to provide continuous fighter cover over the invasion beaches and deep into France proved crucial to the success of Operation Overlord. Production statistics from mid-1944 show the scale of the operation. British factories were producing thousands of paper drop tanks monthly with Bowatta Lloyd as the primary manufacturer, supplemented by other facilities. The entire Allied fighter force in Northern Europe could be equipped with fresh tanks for every mission. Metal tank production, by comparison, remained limited by aluminum availability and required critical resources needed for aircraft production. Colonel Francis Gabreski, leading ace of the European theater with 28 victories, flew his most successful mission on July 5, 1944 using paper drop tanks. Leading the 61st Fighter Squadron to Magnaberg, he shot down 3 Messerschmitt Bf-109s after dropping his tanks near Brandenburg. His after-action report noted perfect tank performance at 30,000 feet despite -40-degree temperatures, clean release when bounced by enemy fighters, and critical improvement in climb rate after release. By September 1944, the Luftwaffe Day fighter force was effectively broken. General Galland reported to Hitler that American fighters were ranging over all of Germany with impunity. The long-range escort had not only protected bombers, but had engaged in systematic destruction of the Luftwaffe through aggressive fighter sweeps. German pilot training programs forced to operate from scattered fields to avoid attack produced pilots with fewer than 50 hours of flight time compared to 400 hours for American pilots. First Lieutenant Urban Drew of the 361 Fighter Group achieved a remarkable feat on October 7, 1944. Flying with two 108 paper tanks, he escorted bombers to Poland near the Polish border, a round trip of 1,400 m. After dropping his tanks, he shot down two Su-62 jets, becoming one of the first pilots to down the revolutionary German fighters. The efficiency of paper tank logistics became crucial during the Battle of the Bulge in December 1944. With forward airfields hastily constructed and supply lines strained, the lightweight compact paper tanks could be delivered by light aircraft or even parachute drop. Captain Jack Ilfrey, commanding the 20th Fighter Group, documented surge operations during the Bulge, noting they flew 3 missions on December 23 each time, with fresh paper tanks with ground crews able to rearm and refuel, including mounting new tanks in 20 minutes. German Technical Intelligence Officer Major Wilhelm Hoffmann, captured in April 1945, provided post-war testimony about the impact of Allied drop tanks to U.S. interrogators. He stated that they tracked every innovation in Allied fighter capability, and the appearance of paper drop tanks was more strategically significant than any new aircraft type. It meant nowhere in the Reich was safe from fighter attack. Their entire air defense strategy based on concentric rings of fighter bases became obsolete overnight. The numbers from the Strategic Bombing Survey were conclusive. In 1943, before widespread use of long-range escort, German fighter production had actually increased despite bombing. By late 1944, with Mustangs ranging over every German factory, fighter production dropped 40%. More critically, fuel production fell 90%, grounding even the fighters that were built. Lieutenant Colonel John Landers, commanding officer of the 78th Fighter Group, flew 103 combat missions, many with paper drop tanks. His assessment provided to Air Force historians in 1962 emphasized that the paper drop tank was the unsung hero of the air war. Simple, cheap, and absolutely essential. Without those British paper tanks, escort to Berlin would have been impossible. And without that capability, the Luftwaffe could not have been broken. The production techniques developed for paper drop tanks influenced post-war manufacturing in unexpected ways. The lamination process was adapted for civilian aircraft components and eventually aerospace applications. The quality control procedures established at Bowater Lloyd became standard in British manufacturing. Workers trained in precision paper construction founded companies producing everything from aircraft interior panels to architectural components. Major Richard Turner of the 356th Fighter Group provided a combat pilot's perspective in his 1946 memoir, calling the paper tanks their passports to Berlin that looked ridiculous but worked perfectly. He flew 89 missions with paper drop tanks without a single failure. Soviet observers attached to 8 Air Force units reported back to Moscow about the paper tank innovation. Colonel Ivan Kajub, the Soviet Union's top ace, tested captured German drop tanks and compared them to American paper tanks in 1945. His report noted the American tanks were superior in every measure through brilliant simplicity, not advanced technology. The production surge for the final offensive into Germany demonstrated Allied industrial might. Every fighter mission over Germany employed fresh tanks. Ground crews at forward bases in Belgium and Holland could equip entire fighter groups in hours rather than days. Lieutenant Robert Powell of the 55th Fighter Group experienced the ultimate test of paper tank reliability on March 24, 1945 during Operation Varsity, the Rhine crossing. Taking off at 0600 with two 108-gallon paper tanks, he flew to the Rhine, dropped tanks when engaged by Mi-262s near Frankfurt, fought for 15 minutes, landed at a forward strip, took on new tanks, and flew another mission, demonstrating the system's flexibility and reliability. The last major employment of paper drop tanks in the European theater came on April 25, 1945, when Mustangs escorted reconnaissance aircraft to Hitler's mountain retreat at Berchtesgaden, a round trip of 1,400 m. The mission demonstrated total Allied air dominance with fighters ranging over the furthest corners of the Reich unopposed. Colonel Benjamin Davis, Jr., commander of the 332nd Fighter Group, the famous Tuskegee Airmen, employed paper drop tanks on escort missions from Italy into southern Germany. His after-action report from March 31, 1945 stated that the 108 tanks allowed them to escort bombers to Munich and engage enemy fighters throughout the mission with perfect performance at altitudes exceeding 30,000 feet. These simple paper tanks gave them the range to prove their worth as fighter pilots. The psychological impact on German civilian morale was documented in captured letters and diaries. Citizens wrote about American fighters overhead constantly dropping fuel tanks made of paper in parks and streets, demonstrating such wealth that they could carry fuel in paper containers and throw them away. Post-war analysis by the Pentagon revealed the strategic importance of the paper drop tank program. The savings in aluminum alone justified the entire program. The reduced shipping costs, simplified logistics, and decreased ground crew requirements multiplied the benefits. Most importantly, the extended fighter range saved an estimated 8,000 bomber crew lives by reducing loss rates from the catastrophic levels of late 1943 to sustainable levels by early 1944. Air Chief Marshal Arthur Harris, commander of RAF Bomber Command, initially skeptical of daylight bombing, acknowledged in his memoirs that the American achievement in extending fighter range through disposable tanks validated their entire strategic concept. General James Doolittle, commander of the 8th Air Force, provided the strategic assessment in his final report. The extension of fighter range through auxiliary fuel tanks, particularly the British-manufactured paper tanks, was the single most important tactical development of the air war in Europe. It transformed the P-51 from a good fighter into a war-winning weapon system. The ability to escort bombers to any target in Germany broke the back of the Luftwaffe and established Allied air supremacy essential for victory. The human dimension of the paper tank story extended to the thousands of workers who manufactured them. At the sitting facility, production workers, 70% of them women, operated 3 shifts to meet demand. They knew every tank they built meant Allied aircrew could fly further and return home safer. The technical specifications achieved were remarkable for such seemingly simple devices. Each 108 gallons tank could withstand 3 gs of acceleration when full, 9 gs when empty. They functioned perfectly across extreme temperature ranges and altitudes. The fuel transfer rate matched internal tank systems, providing seamless transition during combat. All this from compressed paper and plastic resin, materials available in any industrialized nation, but combined with uniquely Anglo-American innovation and production capability. German aircraft designer Willy Messmet, interrogated after the war, admitted they knew about auxiliary tanks and used them, but never imagined mass production of disposable tanks from non-strategic materials. The Americans and British turned a logistics problem into a production advantage. The influence on military doctrine was profound and lasting. The United States Air Force incorporated long-range fighter escort as a fundamental principle, influencing aircraft design through the Cold War and beyond. The concept of disposable components to extend capability became standard, from fuel tanks to sensor pods to weapons pylons. The paper tank proved that innovation didn't require exotic materials or revolutionary technology, just creative application of existing resources. Lieutenant General William Kepner, commander of 8th Fighter Command, summarized the impact in testimony to Congress in 1946. The paper drop tank gave U.S. air superiority over Europe. Without it, our bombers would have continued to suffer prohibitive losses. Without it, our fighters couldn't have hunted the Luftwaffe to extinction. Without it, D-Day might have failed. The environmental legacy was significant, though unappreciated at the time. The total of approximately 15,000 paper tanks dropped over Europe during the war biodegrade within months, unlike metal tanks that became permanent. Hazards. French agricultural reports from 1946 showed no lasting soil contamination from paper tanks, while areas littered with metal tanks required extensive cleanup lasting into the 1950s. The quality control innovations developed for paper tank production influenced manufacturing standards. Worldwide, the demand for absolute reliability in a disposable component drove the advancement of statistical process control later adopted across multiple industries. The realization that simple, good-enough designs could outperform overly complex solutions lowered costs while preserving dependability. The strategic influence extended far beyond World War II. During the 1948 Berlin airlift, transport aircraft employed throwaway tanks derived from wartime paper tank technology to increase range. In the Korean War, upgraded versions were used by F-51 Mustangs operating from Japan. This technology evolved into modern composite materials, yet the core idea, lightweight, expendable range extension, remained unchanged. The final combat use of paper drop tanks occurred on May 7, 1945, just one day before VE Day, when Mustangs from the 357th Fighter Group conducted a last patrol over Czechoslovakia. Lieutenant Robert Foy, flying his 89th mission, recorded carrying two 108-gallon paper tanks to Prague and back, jettisoning them over a farmer's field near Pilsen. Veteran reunions over the decades often featured crew chiefs and pilots reminiscing about their paper tank missions. At the 50th anniversary reunion in 1995 at Duxford, former Luftwaffe General Adolf Galland met with American fighter pilots. When asked to identify the turning point of the air war, Galland pointed toward a displayed paper tank, calling it the simple thing that meant we could never rest, never rebuild. It brought the war to our doorstep every single day until we had nothing left to fly. The apparent simplicity of the design concealed an advanced understanding of material science, aerodynamics, and manufacturing. Each tank embodied thousands of choices about materials, structure, testing, and quality assurance. Its success came from aligning every decision correctly, then executing production at unprecedented scale. Captain Louis Kurds of the 3rd Air Commando Group, who flew Mustangs in both the European and Pacific theaters, compared their impact across environments, noting that the same straightforward solution functioned just as well in the Pacific's humidity as in Europe's freezing conditions, proof of sound engineering that transcended specific operational theaters. The legacy continued in unexpected directions. The phenolic resin technology, developed for tank manufacture, became the foundation of early printed circuit boards during the electronics boom. The lamination presses built for tank production were later repurposed to make television cabinets in the 1950s. Workers trained in precise paper construction went on to establish companies producing everything from aircraft interior panels to architectural laminates. RAF Wing Commander Peter Brothers, who observed American operations using paper tanks, remarked that the Americans treated war as a business problem, buying range by the gallon in expendable containers, with no sentimentality, only ruthless efficiency. The British provided the idea, he said. The Americans gave it mass production, and together they gave the bombers safe passage to Berlin. The final analysis in the United States Strategic Bombing Survey's summary report concluded that the development and fielding of auxiliary fuel tanks, especially the 108-gallon laminated paper model, extended fighter escort range from 475 to 850 miles. This 79% increase brought every German target within operational reach. The resulting reduction in bomber losses saved an estimated 8,000 airmen and allowed the strategic bombing campaign to fulfill its objectives. The story of the paper drop tank highlights a fundamental truth about modern warfare. Victory often rests not on revolutionary inventions but on the clever use of simple, scalable innovations. A British paper company, American Fighters, and resin-soaked cardboard combined to cripple the Luftwaffe and ensure Allied air dominance. The roughly 15,000 paper drop tanks produced, once dismissed by experts as impractical, proved decisive in securing air superiority over Germany. Each functioning tank represented a life spared, a mission completed, a step toward triumph. The bombers could now strike deep with protection. The fighters could engage the enemy on their own ground. The war in the air was ultimately won not through superior aircraft alone, but through greater range delivered by fragile-looking paper tanks that resembled oversized tubes, yet carried the fuel for victory. The innovation emerged from necessity. When metal was scarce and bombers were dying, British creativity met American industrial might, forging a solution so simple it seemed improbable. Paper and resin, newsprint factories and fighter squadrons, converging to solve one of the war's most pressing problems. When Lieutenant William Overstreet flew over Berlin on March 4, 1944, with those paper tanks beneath his wings, he carried the culmination of months of design, experimentation, and production, by thousands of unseen workers whose efforts were as vital as any frontline victory. The paper drop tank remains a testament to the power of practical innovation over complexity, proving that sometimes the greatest solution is not the most advanced, but the one that can be achieved at scale when it matters most.